Hi everyone. Tonight we're going to talk about operations of functions. If f and g are functions, then the functions f plus g, f minus g, f times g, and f divided by g are defined as follows. So if you're adding two functions, basically that just means you could use any three of these notations. They all mean the same thing. F plus g of x, and f of x plus g of x. And if you're subtracting two functions, again, you could use all three of these notations. F minus g of x, or f of x minus g of x. They're all equal to each other. If you're multiplying functions, again, you could use f times g of x, or f of x times g of x. You're probably getting the idea, but same thing with division. F divided by g is the same as f divided by g of x, which is also the same as f of x divided by g of x. Okay, let's look at some examples. If f of x equals 3x squared plus x and g of x equals 4x minus 2, then find f plus g, f minus g, f times g, and f divided by g. Okay, so first we're going to add the functions. So f plus g of x, remember that equals f of x plus g of x. Basically, you're just adding both functions. So that would become 3x squared plus x plus 4x minus 2. And then we'll just combine like terms. So we get 3x squared plus 5x minus 2. And that would be the sum of f of x and g of x. All right, let's look at subtraction. F minus g of x is equal to f of x minus g of x. Now, when you're subtracting, it's important to put the second function in parentheses. So in this case, g of x. So we get 3x squared plus x minus 4x minus 2. And the reason you want to put g of x in parentheses is because you have to distribute the negative. And that's a common mistake that I see often. People forget to distribute that negative. So this will become 3x squared plus x minus 4x plus 2. And again, we're just going to combine like terms. 1x minus 4x is negative 3x. All right, let's look at multiplication. So remember that f times g of x is equal to f of x times g of x. So since we're multiplying the functions, I'm going to put them both in parentheses. And so here, we are going to FOIL. 3x squared times 4x is 12x cubed. 3x squared times negative 2 is negative 6x squared. X times 4x is 4x squared. And x times negative 2 is negative 2x. And then we can combine our like terms. Negative 6x squared plus 4x squared is negative 2x squared. All right, let's look at the last one. So f divided by g of x, remember, is equal to f of x divided by g of x. So again, f of x is 3x squared plus x divided by 4x minus 2. And sometimes you can simplify by factoring, but here I notice we could factor an x out of the numerator, which would leave us with 3x plus 1, but it's not going to reduce. with anything, so I probably would just leave it like this. Either answer is fine. Okay, let's move on. Sometimes you are going to be given a value for x. So in this example, you see we have g plus f of 8. So this time we know x is equal to 8. So there's a couple different ways you could do this. You could add the functions first, combine your like terms, and then plug in an 8. Or you can plug in an 8 into each function first and then add. So we're going to do that because remember that if we have g plus f of 8, that would equal g of 8 plus f of 8. So let's just find each of these. So g of 8 would equal 8 minus 10, which is negative 2. F of 8 would equal 3 times 8 minus 5. So 3 times 8 is 24, minus 5 is 19, and so then we can just add the negative 2 plus 19, and we get 17. Okay, same idea over here. We have f minus g of negative 3. So that is the same as f of negative 3 minus g of negative 3. My negatives aren't showing up. Okay, so let's find each of these first. So f of negative 3 would equal 3 times negative 3 minus 5. So 3 times negative 3 is negative 9, and negative 9 minus 5 would be negative 14. And then g of negative 3 would equal negative 3 minus 10, which is negative 13. And so then we're just going to take negative 14 and subtract negative 13, going back to this. And because we're subtracting a negative, that'll become adding a positive, and then we'll get negative 1. All right, I think we'll stop there. Okay, let's look at the next set of notes. So now we're going to talk about compositions of functions. If f and g are functions, then the composite function of f and g is, now, I know you've seen both notations before. The way you read the first one is f of g of x. The second one, a lot of people like to read this as fog. That's not actually correct, though. The correct way to read it is f circle g of x. And both notations represent a composition of functions, which is a way of combining functions where you use the output of one function as the input of another function. So this is where you're actually like plugging one function into another function. Let's look at some examples. If f of x equals 3x minus 2 and g of x equals x squared, then find f of g of x and find g of f of x. So let's start with the first one, f of g of x. Okay, so what I usually tell my students is start with the outside function, which is f, which is 3x minus 2. And wherever you have an x, just put a set of parentheses. Because what we're going to do is we're going to take g of x and we're going to plug that into the parentheses. So you can see where we're actually taking the x squared and plugging it in for x. And then basically we could just clean it up and write it as 3x squared minus 2. Okay. Okay, now let's find g of f of x. So that means we're going the other way now. Okay, but again, start with the outside function. Start with g. which is x squared. So I'm just going to put a big set of parentheses, squared. And then inside the parentheses, we're going to plug in f of x. So that'll be 3x minus 2. All right, now to simplify this, or work it out, we would have to FOIL this, because remember, 3x minus 2 squared means 3x minus 2 times 3x minus 2. So if we FOIL, we're going to get 9x squared minus 6x minus 6x plus 4. And then we can combine our middle terms. Negative 6x minus 6x is negative 12x plus 4. All right, and then just like with addition, subtraction, multiplication, and division, sometimes we're given a value for x. And so here, we're going to find g circle f of negative 2. Okay? Now, I kind of like to take this notation and rewrite it as g of f of negative 2, because I think it's just a little bit easier to see what's happening, like what's being plugged inside of what. So in this case, you want to start with the inside. We actually want to start by finding f of negative 2 first. So let's do that, which means we're going to plug in negative 2 into f of x. And then we're going to work it out. So we're going to get 4 minus 1. So that'll equal negative 1. Okay, so notice how f of negative 2 is inside g. Okay, so basically now we're going to find g of negative 1. Okay, because we already found f of negative 2, and we know that that is now negative 1. So I'm really just like replacing f of negative 2 with negative 1 back up here. Okay, so g of negative 1 means we're plugging negative 1 in for g, so that'll become 1 over negative 1 minus 3, and that's going to equal basically negative 1/4. Let me move it down a little bit. Come on. Negative 1/4. Okay. All right, let's look at example B. So here we're finding f of g of 5. So again, we want to start on the inside. Find g of 5. So that's going to equal 1 over 5 minus 3, which is 1/2. Okay, so now we're going to take that 1/2 and we're going to plug it into f. So now we're going to find f of 1/2. So you can really see here how the output of one function becomes the input of the other function. Okay, so we're going to have 1/2 squared plus 2 times 1/2 minus 1. Okay, so let's work this out. 1/2 squared, whenever you're squaring a fraction, you square the numerator and the denominator. And then here, we're multiplying 2 times 1/2. Well, remember, 2 over 1, 2 as a fraction, basically you just put a 1 under it to change the 2 to a fraction. And then multiply straight across. So that would become 2 over 2, which would equal 1. And then we'll bring down the minus 1. And so this one worked out nicely because it ends up equaling 1/4. And now we are finished. Okay, we are going to practice this a little bit more in class tomorrow. See you then.